Okay, get ready for this. AI. It started as just clever chatbots, right? But now it's exploding into something way beyond that.
Absolutely. We're talking about AI that doesn't just talk, but learns, plans, even acts on its own. It's quite the transformation.
It really is.
Yeah.
So today we're going to chart that journey. We're looking at how generative AI went from just generating text to, well, systems that have real agency.
Exactly. We'll break it down into sort of 3 key stages. You'll get a clear picture of the evolution, the LLMs, then RG, and finally agentic AI.
And the goal here is pretty simple, right? We want you to really grasp what each stage means, what they can do, what they can't do, and, how they're actually showing up in the world.
Mm-hmm. And we'll try to keep the heavy tech jargon to a minimum.
Right.
It's about understanding the concepts and the impact.
Perfect. So buckle up. Let's start at the beginning. Large language models,
Yeah.
LLMs.
Right, the foundation. These are really the building blocks for everything else we're seeing now.
LLMs. I remember Dario Amodei from Anthropic called them sophisticated autocomplete systems. Is that a fair way to think about them at their core?
It's a great starting point, yeah. A very insightful analogy. Fundamentally, they are incredibly powerful prediction engines.
Prediction engines, meaning?
Meaning they've been trained on just vast, vast amounts of text data. We're talking trillions of words or tokens.
Trillions.
Trillions. And that lets them predict, with remarkable accuracy, what the next word in a sentence is likely to be.
Okay. And how do they manage that? What's the tech behind it?
The breakthrough was really the transformer architecture. It lets the model weigh the importance of different words in a sentence to understand context.
Ah, right. Context is key.
Exactly. And the scale is just immense. GPT-4, for instance, is estimated to have over 1 trillion parameters.
1 trillion parameters. It's hard to even wrap your head around that number. So what can these things actually do? What are the practical uses?
Oh, they're already everywhere. Content generation is a big one. Articles, marketing copy, even creative writing prompts. They're helping programmers write and debug code. They power a lot of customer service chatbots.
Yeah, I've definitely interacted with those.
Right. And in education, they can explain concepts, act as tutors.
Yeah.
Oh, and translation, of course. Big impact there.
That's a pretty impressive list. But these first-generation LLMs, they weren't perfect, were they? They had some significant drawbacks.
Definitely not perfect. A major one was the knowledge cutoff. They only knew things up until their training data ended.
So no current events, basically.
Exactly. And they couldn't access external resources, no live internet, no specific databases. They were kind of isolated.
Okay.
Then there's the issue of hallucinations.
Ah, yes. Making things up but sounding confident about it.
Precisely. Factually incorrect information presented as fact. Plus, they had no real memory beyond the current conversation window.
Right, context windows.
And critically, they were purely reactive. They only responded to prompts. They couldn't initiate actions themselves.
Got it. So who are the big players now? What models should people know about?
Well, you've got OpenAI's GPT-4o, famous for its huge context window, like 128,000 tokens.
Yeah.
It can handle really long documents or conversations.
Okay.
Google's Gemini claims an even bigger window, over 1 million tokens, though practical use needs evaluation. And Gemini is multimodal text and images.
Interesting.
Anthropic's Claude is known for being very conversational, with a focus on safety being helpful, harmless, and honest.
H.
Right? And Meta's Llama 3 models are significant because they're open weight, which fuels research and commercial use.
So lots of development happening there, but that limitation, the lack of real-time info, that seems like a big hurdle.
It was. And that's precisely where the next step, Retrieval-Augmented Generation, or AGI, comes in. It's about connecting the LLM to the outside world.
RAG Percy Ling at Stanford called it a critical bridge, right?
Exactly. A perfect description. RAG is designed specifically to fix that problem of LLMs being disconnected from current or specialized information.
Okay, so how does this bridge actually work? How do you give an LLM access to external knowledge?
The core idea is pretty clever. Combine the LLM's ability to generate text with a separate system for finding relevant information first.
Finding info first. How?
It usually involves 3 steps. First, you index your knowledge sources, documents, databases, whatever. You turn them into numerical representations, embeddings, basically.
Embeddings, like coordinates for meaning.
Kind of, yeah.
Yeah.
It allows for efficient searching based on semantic similarity. So, second step, retrieval. When you ask a question, the system retrieves the most relevant chunks of information from that indexed knowledge base.
Got it. Finds the right paragraphs, essentially.
Pretty much. Then third step, generation. The LLM takes your original query plus the retrieved information and uses both to generate a much more informed, grounded answer.
Ah, so it's not just guessing anymore. It has specific facts to work with. That sounds like it solves a lot of the earlier problems.
It really does. RA tackles knowledge recency head-on because it can access up-to-date documents.
Makes sense.
It allows for specialized knowledge. You can feed it company documents, medical journals, legal texts, whatever is needed.
Right, domain-specific stuff.
Exactly. And because the answers are based on retrieved documents, it drastically reduces hallucinations.
And you can check the sources.
Often, yes. It provides verifiability, which is huge. Plus, it helps keep the context focused by only pulling in the relevant bits of info.
Okay, this sounds incredibly useful. Where is RA actually being used now? Can you give some examples?
Oh, it's popping up in lots of places. Think enhanced enterprise search tools like Elasticsearch. Use it so employees can find answers in massive internal knowledge bases.
Right, searching company wikis and stuff.
Exactly. Knowledge management systems generally. In law, you have tools like Harvey or Casetext using RAG to find relevant case laws super fast.
Wow.
Customer support platforms Intercom, Zendesk use it to pull answers from company-specific help docs. Even healthcare, like Mayo Clinic, exploring it for referencing medical literature.
That's really powerful. I read about a media company cutting research time by, 70% using RAG?
Yeah, that was a striking example, 7%. It shows the real-world efficiency gains possible.
Absolutely. But even with RAG, these systems are still fundamentally reactive, aren't they? They find info and answer questions, but they don't do things on their own.
That's the crucial point, yes. RAG is a massive step up for information access and accuracy, but it doesn't initiate actions. It doesn't have goals. It pursues independently or complex multi-step planning capabilities.
Okay.
It doesn't learn over time from its interactions in that sense either.
Which leads us neatly into the next phase, the really cutting-edge stuff, Agentic AI.
Exactly. This is where things get really interesting, moving beyond reaction to proactivity.
Agentic AI, it implies agency, right? Real independence.
Precisely. Ilya Sutskever from OpenAI put it, well, it's the shift from just predicting text to actually doing things in the world. These are systems designed to be goal-oriented.
Okay, so what defines an AI agent? What makes it different from an LLM or a RAG system?
Several key capabilities come together. First, autonomy, the ability to operate with minimal human supervision to achieve a goal.
Right. Less hand-holding.
Much less. Then, memory. Not just the short-term context window, but persistent memory, short-term working memory, long-term storage, often using those vector databases we mentioned to recall past experiences and information.
So they can learn and remember across interactions.
Yes. And planning is crucial. They can break down a high-level goal into smaller executable steps, strategize, prioritize.
Okay, that's a big step.
Huge, and maybe the biggest differentiator of tool use. They can access and operate external systems, databases, search engines, APIs, software tools. Basically interact with the digital environment.
Like giving the AI hands and tools to work with.
That's a good way to put it. All this drives their goal-oriented behavior, and they often have feedback loops to learn from results and adjust their approach.
Wow, tool use, planning, memory. So are there actual examples of these agents out there yet? Or is it still mostly theoretical?
Oh no, we're seeing real examples emerge, and they're pretty groundbreaking.
Yeah.
Devin from Cognition Labs caused a huge stir.
Ah, the AI software engineer.
That's the one. It's designed to be an autonomous software engineer. It can supposedly understand requirements, write the code, debug it, even deploy the application.
Seriously, end to end.
That's the claim. It can apparently learn unfamiliar technologies, build and deploy apps, fix bugs found in open source projects, even tackle real programming jobs from platforms like Upwork.
How does it do that?
It operates in a sandboxed environment with developer tools, shell, code editor, browser, allowing it to perform tasks like a human developer would. Its performance on the SW benchmark was significantly higher than previous systems.
That's incredible. What else?
There's AutoGPT, which was an early influential open source experiment showing an AI autonomously working towards user-defined goals using command loops.
Right, I remember that making waves.
GitHub Copilot X is also evolving, adding more agent-like features to help developers. And Baby AGI is another interesting example, a task management system that uses LLMs to create, prioritize, and execute tasks in a loop.
So the focus is really shifting from answering questions to getting tasks done. Where else are people starting to use these beyond the big headline examples?
We are seeing early adoption, or at least serious exploration, in a few areas. Software development, obviously automating coding, testing, debugging. Marketing is another, envisioning agents that create, schedule, and optimize campaigns. Customer service, potentially moving towards end-to-end ticket resolution without human intervention.
That would be a change.
Definitely. And research agents assisting with designing experiments, gathering data, analyzing results. I even heard about an e-commerce startup using an agent to manage inventory pricing and product descriptions autonomously.
Wow. Okay, what about big companies? Enterprise applications, where could this really shake things up?
The potential there is enormous. Think about AI ops, IT operations. Predicted agents could proactively spot and fix issues before they even impact users.
Proactive IT, that's the dream.
Right. In healthcare, maybe multi-agent systems, working with RDAG to interpret complex medical scans more effectively. Developer productivity tools will just keep getting more powerful. And then there's enterprise workflow automations, streamlining all sorts of complex business processes, insurance claims, logistics, finance, HR onboarding, invoicing, you name it. Companies like UiPath and Automation Anywhere are already pushing into this space.
So automating complex workflows across different systems.
Exactly. But it's important to temper the excitement slightly. While the potential is huge and progress is fast, widespread deployment of truly capable, reliable agentic AI across the enterprise, we're not quite there yet. It's still early days in many respects.
Okay, that makes sense. So we've gone from LLM just predicting words to RG adding knowledge to agentic AI actually taking action. Can we just crystallize the key differences between these three stages, like a quick comparison?
Yeah, definitely. Let's break it down.
Architecture.
LLMs use transformers. RG adds a retrieval module. Agentic AI builds on that with memory, planning, and tool use capabilities.
Data source.
LLMs rely on their training data. RRig pulls from external knowledge bases. Agentic AI interacts with the real world via tools, gathering data dynamically.
Autonomy.
Low for LLMs needs prompts. Medium for R retrieves info autonomously but needs correction. High for agentic AI operates independently towards goals.
Memory.
LLMs have limited context window memory. RAG uses retrieved info for context. Agents have persistent short and long-term memory.
Planning.
None in basic LLMs. RAG doesn't plan, but might retrieve plans. Agents do explicit goal-oriented planning.
Tool use.
None for LLMs. Limited to retrieval tools for R. Extensive tool use is core to agentic AI.
And the main capability.
Text generation for LLMs. Enhanced rounded text generation for R. And autonomous task execution for agentic AI.
That's a great summary. You can really see the progression, each stage building on the last, adding more capability and independence.
Exactly. And we're even seeing hybrids emerge, like agentic RAG, combining that external knowledge access with autonomous action.
Fascinating. So bringing it back to the real world, again, we mentioned some examples, but just to reiterate, where are people bumping into these different levels of AI right now?
Well, LLMs are mainstream now. You use them in ChatGPT, Gemini, Copilot for everyday tasks, writing emails, getting quick answers.
Daily use for many.
RRig is often working behind the scenes. When you get a really helpful answer from a customer support bot on DoorDash or LinkedIn, RE might be involved, pulling from their specific knowledge base.
Okay. Less visible, but improving the experience.
Exactly. And agentic AI, well, Devin is the poster child right now for its potential in software engineering.
Yeah.
GitHub Copilot is another widely used tool that's moving in that agentic direction, helping developers achieve tasks more autonomously.
Got it. Looking forward now, what are the big picture implications? If AI continues down this path towards more agency, how does that change things? Work, society?
The implications are potentially massive. For work, expect significant shifts. Yes, automation of routine tasks, maybe even some complex ones.
Job displacement concerns.
That's definitely part of the conversation. But also, new roles will emerge. Managing these AI systems, developing them, collaborating with them. Software development, as we discussed with Devin, could be revolutionized faster cycles, maybe freeing up humans for more creative or strategic work. Some estimates, maybe 30% of software work hours could be impacted by automation by 2030.
30%.
Yeah.
Wow. And beyond work, society.
Huge potential benefits. Healthcare agents assisting diagnosis, maybe even aspects of patient care. Education, truly personalized learning assistance. Accessibility improvement. Tackling complex societal problems might become more feasible. But there are challenges too besides jobs. Ethical questions, control, bias. We need to be mindful. Experts are certainly thinking big though. Bill Gates talks about proactive agents learning us. Satya Nadella sees AI becoming the main way we interact with computers. Gartner predicts 80% of common customer service issues handled autonomously by 2029.
80%.
Yeah.
That's a fundamental change. But you mentioned challenges, ethics. Agentic AI sounds powerful, but also potentially risky. What are the current limitations and the big ethical hurdles we need to consider?
Absolutely. Technically, there are still significant limitations. Complex, long-range planning is still hard for them. They can become over-reliant on their tools or fail if a tool doesn't work as expected.
Okay.
They still need human oversight, feedback, correction. Memory isn't perfect. Models like Gemini can still confuse sequences. GPT-4o can lose track of details mid-conversation. Reasoning, especially causal or counterfactual reasoning, is still limited.
So they're not super intelligent general problem solvers yet.
Not by a long shot. They're often domain-specific. Discovering and learning to use new tools effectively is a challenge, and error recovery can be brittle.
Makes sense. And the ethical side.
That's critical. How do you ensure control and accountability when systems act autonomously? What about unintended consequences?
Right. If an agent makes a mistake, whose fault is it?
Exactly. Bias is a huge concern. Agents inheriting biases from the LLMs they're built on or the data they access. Job displacement we mentioned. Security is a massive area. Prompt injection, insecure tool use, data poisoning, denial of service attacks, adversarial instructions.
Yeah.
The attack surface grows.
Because they can act, the potential for harm is greater.
Precisely. Privacy is another big one, especially as they access more data and tools. We need transparency, understanding why an agent made a decision. Fairness, ensuring they don't produce discriminatory outcomes. It all points to the need for really responsible development practices, strong guardrails, ethical guidelines, and governance frameworks.
A lot to think about and get right as these systems become more capable.
Absolutely critical.
Okay, so wrapping up this deep dive then, we've journeyed from LLMs just predicting text, through RA connecting them to knowledge, to these emerging agentic systems that can plan and act.
It's been an incredible acceleration. The key takeaway is this clear trajectory towards increasing sophistication and autonomy. AI is moving from processing information to potentially acting intelligently within the world.
The potential seems immense, promising transformations across almost every field.
It really does. But realizing that potential safely and beneficially means continued research, innovation, and a serious commitment to tackling those technical and ethical challenges we just discussed.
Definitely. And maybe a final thought for you listening. As these intelligent agents become more common, what skills do you think become most valuable for us humans? How do we best collaborate with, manage, and leverage these increasingly capable systems? Something to mull over.
That's a great question to ponder. It's been a fascinating discussion. Hopefully this gives everyone a clearer map of where AI is heading.
I think it does. A big thank you for joining us on this deep dive.
My pleasure.
And thanks to all of you for tuning in.